Thank you very much for having me today. So as Nick said, I am here to talk about Nuneham Viaduct. But before I do that, just a quick introduction on myself. Claudia Philps. I am a senior portfolio manager for capital delivery, buildings and civils, and based out of Swindon, but covering all of Wales and Western. And with the civils institution, within the civil discipline, my world is the reactive and maintenance space. So if something goes slightly awry with structures, I'm the person who will phone to look at how we're going to resolve this. So that's how Nuneham became part of my work bank. So just a little bit of history for those who are not aware about the structure. The structure itself has been through a number of iterations over the course of 150 years. It was rebuilt a couple of times. And the really important thing for me with this is that whilst the superstructure had been rebuilt over the course of that 150 years, this southern end low mileage abutment, if I just go back to the main picture, this side here, hadn't been rebuilt when the rest of the superstructure had. So this element was 150 years old, whereas the rest of it was much closer to 100 years old, which for the purposes of this is important in that you have an asset that's got different ages, different standards that were applied to it, different expectations. It was built in a different era to where we are now. So the issue we had with Nuneham Viaduct is that it had been a problem, I've called it a problem child, for a little while. We had moved from a general ad hoc tamp occasionally through to needing an annual tamp, through to needing more like 6 monthly tamps, and getting right down into the space where both roads were needing significant maintenance intervention. I put these pictures up of the track condition the day we closed it. But as you can see, we'd really moved into a space where the track geometry was almost impossible to keep where we needed it to be, with maintenance interventions very regularly. The risk had been managed through speed restrictions, and we did do a lot of investigation in late 2022 trying to find the root cause, not just solve the symptoms. There were plans afoot and work streams ongoing to try and get to a position where we could stabilise the whole asset, be it earthworks, structures and the track disciplines. This is a multidisciplinary issue. That transition between earthworks and structures with the track across the top, we know that interface can be quite interesting and quite challenging at times. So we had moved to a position on the 3rd of April where it was concluded as a business that the track had become unsustainable and the track geometry became unsustainable and the line was closed to traffic. There were other symptoms, not just the track geometry, that there was something amiss here. There is a photograph there of the wing wall. And as you can see, you've got significant cracking through that, which suggests that there is this differential between the land either side and the bridge itself, where the structure was settling relative to its adjacent banks. So this is essentially what I'm considering day one for the purposes of today. There's lots of history to it that's incredibly interesting in itself, but I'm going to focus on how we resolved the issue once we had arrived at the railway needing to be closed to traffic. So day one, Monday the 3rd of April, about 10:30 a.m, we closed the traffic. We already had some level of mobilisation on site because we were working through the options to stabilise the structure. So there was already a presence through my principal contractor, Balfour Beatty, and their designers, Crouch Waterfall. And we were looking at all of this. So some of this is a little bit of a standing start. It wasn't quite from zero. We have a small presence on site already. Now, this first week, and this first slide is one of my big lessons learned for the whole job. On day one, when we closed it, we had senior leaders within the Western and Wales region come to site, have a look at it, try and help us work out how we can solve this as quickly as possible, open the railway to traffic. This is an incredibly important route for the country in terms of freight north to south and passengers, Oxford, Didcot into Paddington. Incredibly important strategic and tactical route for the country. So getting the operational railway back, fundamental. So day one and day two, we asked people to come to site internally, nationally, within Network Rail. External university professors have come to site. All were looking at this from slightly different angles, fresh eyes. Come and have a look, please. Share your experience with us as to how we can move this forward and expedite any solution to get trains running. Everyone came to site, understood the issue, and we all concluded that actually there wasn't something we could do in a 24-hour period that got the railway up and running again, that we'd moved into a space that this was fundamental and we needed to solve the root cause as opposed to address the more immediate symptoms. So that's day one and day two. We then spent day three into day four looking at all the options with regards to how do we bring the bridge back into its, do we try and stabilize it where it is? Do we try to bring it back horizontal? Do we try to do a solution that allows a speed restriction upon opening, or do we go for the full 90 miles an hour again and solve the problem once and for all? And we worked through those workshops with designers, the contractor, specialists, and really importantly, asset management were drawn into those conversations such that the assurance processes were concurrent, were developed with the solution, and we had everyone's buy-in as we went. At the same time as this, I'm discussing with the Environment Agency, I'm discussing with the landowners, I'm discussing with all the consenting people such that everyone is bought into this plan as to how we might resolve it without numbers to the engineering, but the experience in the room allowed us to come up with a beautiful cartoon drawing of the plan. So by day five, we kind of knew what we wanted to do. We understood it was feasible, and we were working to one plan that people had bought into, right from the top of Network Rail into the TOCs and the FOCs, and we understood where we were heading. And on day five, on the Friday, 7th, we put timescales to this, and we said we think that activity is going to take us 7 days. That's going to take us 9 days. We thought about the procurement, and we came up with the conclusion that we'd open to traffic on. We thought it was going to take us 67 days, which was going to be the 9th of June. That was the date. So within day 4, we told the BBC, everybody, this is the day you're going to have the railway open, with the speed restriction because you have a TAMP to follow, but essentially the solution would be for line speed. Pretty bold, and I think quite a few people were not sure. Sometimes the railway doesn't have the best reputation for sticking to a deadline, but we had actually, because we had spent 3, 4, 5 days with the right people in the room, really considering and not being rushed into giving a date. We wanted to make sure the date we gave was credible and based on real understanding of the problem, and understanding of lead-in times and what we could achieve and where we could be. And for me, as a lessons learned, taking that time and being strong enough on day 1, day 2 to say, let me think about this, and I will give you a valid, well-rounded, credible plan by the end of the week. This is day 5. I've been through a number of different people with lots of different disciplines. For me, was incredibly important starting point, and it gave us a really solid foundation, no pun intended, to the project, to where we're heading. So I'd really recommend understanding your risks, where you're heading, and having the right people in the room. And then, because we've done that, everyone has some confidence in the plan, and I think that really worked out for us. So as you can see, the cartoon 11 steps to opening the railway, we actually did exactly that. The plan, we did that. It did not change from day 4, and we worked through it, and the timescales are pretty much there. We might be in 12 or 24 hours out on some of the milestones, but we were bang on because we'd thought of it through. So step 1 was removing all the track and all the dead load. This happened over Easter weekend. we used McCulloch's to get the track out, and we actually used a big vacuum to remove all the ballast. We had been monitoring the structure throughout, and we did see it. We did see the change in its physical position as we removed that dead weight. We did see it lift a little bit because the weight was so significant on it. At the same time as doing that, we'd closed the river underneath it. We had the southern span was closed to navigational traffic before we started to consider propping the bridge. So obviously, as you can see in that first photograph, we had to close it to traffic of the river in order to put these piles in. The main thing with the bridge, and once we decided to go for the I'm going for line speed solution, was bringing the bridge back up to horizontal. The way we could bring it back up to horizontal, we physically have to prop it up and jack it up. With the proximity of the abutment to the riverbank edge, there wasn't anything we could do in that small space, so we had to work within the river channel. And because this is day 10, 15, something like that in the programme, this is very early on, the procurement lead-in time, we haven't had that opportunity to start talking about different types of piles that we can be using to get the loading conditions, how we do this. So actually, the piles that we put into the river, there was 24 of them, are old OLE piles that were previously at Morton Cutting, and some down from south, to reuse what we had in terms of understanding the early availability of material. We understood its properties, we understood the lengths of it, and we understood where we were heading. So as in terms of reutilising materials available, we scoured our area for those OLE piles, which worked really, really well. They were driven in, and the Movax actually was sat on the pontoon. We had a pontoon, and we all worked from the river. There was a machine on a pontoon, and we worked entirely from the river. So this was a really interesting phase, and I think we'd all moved into a space where everybody on the project, this was novel for us, and so relying on our expertise of the supply chain, who are really familiar with working around water and the river, and done some really interesting jobs pulling on Timoth Maritime Solutions to kind of say, actually, you're an expert, come and help us. Relying on those suppliers was fantastic for the whole project. Once we put the piles in, we needed to put the propping system in. Now, because of the weight of the propping system, we had to have a pretty significant size crane. That's a 750-ton crane to lift all of this in. We couldn't, based on the programme, afford to do this piecemeal, bring it in piece by piece and connect it all up on site over a river with minimal working platforms. The safety, the programming didn't work. So we actually put together the trusses that the propping system was jacked off, or the jacking system was off. We put them all together separately in Maybe's yard, and we brought them in and lifted them in, which again, from a programming perspective, it required that forethought to know that's going to take too long in our program. Let's fabricate off site. So we put the propping system in, and the propping system in, and we started to jack it up. I can tell you that Sunday was a pretty stressful Sunday, lifting the bridge over 750 mil. It was a significant lift, doing it in increments. We had watch people all over the structure looking at different elements. We had experts under the structure. We had controllers on the crane pad outside of the structure. And actually we had where the bearings of the superstructure and the abutment were sat, that was a pretty seized joint. So actually there's quite a few moments where you're trying to really separate the superstructure from the abutment, which requires some brute force in the end. What's really interesting on this section is that there is a water pipe, or it's a redundant water pipe, Thames water pipe, that runs along the structure and back out into the fields adjacent. So we liaised really closely with Thames Water, and they were fantastic help, understood the concerns we had, that in order to lift the bridge, we had to remove parts of their pipe because we just didn't know what was going to happen to their cast iron pipe. So we'd removed that pipe with Thames Water's agreement. Once we had the deck up in the right location, all jacks locked off, we demolished the abutment and the embankment. We took out about 5,000 tons of material, and we actually got down to, I don't know if anyone saw the Twitter video or saw the feed, around the ground we found at the bottom of our excavation. It was incredibly spongy. There was lots of different words used at the time with regards to how it felt to be underfoot, but it felt very trampoline-y was the word, like a trampoline was the word I used at the time. And this is the step where I would pause to talk about the second lessons learned about the job. The media comms we did as we went through all these phases was incredibly important. I think how successful the project was received, because closing the significant train line in exactly this location was detrimental to a lot of businesses, a lot of people's commutes, and a lot of the way people interact with the railway. So we put out weekly videos on Twitter. The BBC were welcome, ITV came to site, and we did news pieces and said, look what we're doing. This is really big engineering. We're solving the problem. We're on programme, and brought people on that journey with us. And for me, that was a really big lessons learned for the project, of not hiding away, being really open about what we're doing, how we're doing it. Come and look at what we're doing. And as you can see from those photographs, it's quite impressive when the bridge is jacked up like that, locked off, and there's quite a significant excavation there. So again, huge lessons learned about being really open with our stakeholders. Once we've got to the bottom, we've removed everything, we've removed the problem, we now need to put back. We ended up with some pretty significant piles. That upper left picture, the piles actually go in about 19 meters. They are significant. We didn't find solid bedrock. We didn't find some at solid base. So these piles had to go really deep to get that friction associated with those piles. The crane, we had cranes to hold the piles up. We had a crane to do the actual driving, because as you can imagine, once they're that tall, these are huge pieces. The size of the machine needed to actually drive these in was quite significant. We have 6 really big piles, CHSs, circular hollow sections, that are taking the abutment weight, taking the superstructure deck weight. And behind them is another row of piles, which are essentially retaining the embankment. So you have 2 separate pile lines that are acting in conjunction. They are connected by these sill beams and pile caps. So there is an element of connection, but they are working for different purposes. And I think for me, this photo on the bottom right just shows the scale of what the excavation we were working with, the size of the piles we were working with. This is a finished position. We're working on a significant piece of work, and I think sometimes the drone shots don't just suggest the scale, whereas our welder down here, I think, really gives it scale as to the piles, the amount of piling that had to go in. Piling took us quite a long time because we had, as I say, big circular hollow sections, lots of sheet piles, some box sections as well. This stage took the longest in the programme, and it was quite daunting on the programme to see how long we thought this was going to take. These are bespoke for us. The procurement lead in time was played into these, and actually the sheet piles on this on the eastern side are all 100% recycled material that they're standard sheet piles, but had gone through a sustainability certification, which was really positive to have, given the scale of the works. And then essentially backfill. Let's just fill in the hole that we've spent 8 weeks digging. Again, we had to bring in a lot of material, all engineered, all in the right layers, and we had to compact it at specific layers to make sure we got the right level of compaction throughout. We were knocking on 5,500–6,000 tons of material coming back in, and again that took a long time to bring in. But because we'd created a non-railway environment by closing the railway, we'd taken it out, we'd put a section C in, we could use civil contractors for the subcontractors for this rather than railway contractors. So they had different kit available to them, different expertise, different expectations. So again, using the supply chain to their skill set and where we're heading. Where we had put the piles in, we need to do a load of steel work. We'd had to take parts of the bridge out to fit these piles in, so we had to build the bridge back up. It is all lead paint covered, so we had a lot of encapsulation to do through these phases. It's working over a river with lead paint. You know, there's a lot of additional work to be considered to make sure that it's safe for the team and for the river and the river users and river fish. Trying to think of a better word than fish, but fish. The steel work was an interesting stage because we had to waterproof it. We had to take the previous waterproofing up, put the waterproofing back down, fresh steel come in, make it work with the new geometry of the bridge, tie it back in, weld it. And actually the accuracy on a project that we have done this design with as-builts, because we've been designing iteratively as we've gone through. The design for the steelwork was based on as-builts of the piles, so really that accuracy was built in through it. We weren't working from a set of AFCs that had been dealt with previously, and that iterative assurance had been agreed off by our technical authority, and a lot of people had looked at how we'd done that iterative assurance. And then we're into what I'd consider track renewals. We got all the way up to sand level, and then it was a track renewal, which is kind of our bread and butter. This went in very, very quickly, which was really interesting to see as someone who's more of a civils background, seeing the track go on so quickly, nice and easily, and a tamper comes in, which was really interesting to see, as I say. And because that went in slightly quicker than we'd anticipated, we handed back 24 hours early, and we'd hit every milestone we intended to hit as we went through, and we were able to hand back. The first train went through on the Friday morning versus the Saturday morning, which it should have been, which was fantastic to see. The ballast dust went everywhere, so the video doesn't look like isn't that impressive because the ballast dust is everywhere, and the speed restriction was on for the fact it was a track renewal, and we did a follow-up tamp a few weeks later to raise the line speed. At this point, before we head into reinstatement, the third lesson learned that I wanted to bring through was that we'd had to rely on, to get to this stage, a lot of different subcontractors and a lot of different disciplines, and everyone had come to the table and brought their knowledge. And for me, everyone left their badges at the gate. We were a single team and everyone pulled together, and the fact that everyone was rowing towards this date, everyone knew this was the date, we're all going to hit there, everyone had bought into the plan, and being really clear with that expectation, listening to people's concerns and people's expertise, what innovation they can bring, was fundamental to achieving that deadline in terms of handback. So I really think going forward, then lessons learned, that setting that standard up at the front to say, this is one team and this is what we're aiming at as a gang, as opposed to this supplier, that supplier. And what goes up must come down. So we actually had quite a long programme regarding removing the propping from the river, removing the piles from the river. We actually ended up cutting them below riverbed level. We got divers in. The photos aren't great because they're all underwater, so I haven't shared them. But we cut the piles off below riverbed, allowed the riverbed to resettle, and you wouldn't know we'd been there in terms of the riverbed. And you can see our compound here, halfway up the field, and that's the best part of a mile, that whole road, and we essentially had to undo ourselves entirely. We closed the gate on the 30th of September, And so all in all, we're talking 6 months from the day we said hello to the day we said close the gate and thanks the landowner for their support in trying to do what we did. And overall, it's an incredibly interesting project that we got there exactly like we said we would on day 4, and that's only kind of happened because we brought the right people into the room and everyone wanted to be in the room. That's the kind of why we did it. And really, they're just some suppliers, but I've whistled through that really quickly because I'm conscious there's probably going to be a few questions that might come up, and really it's open to the floor, Nick, about where you want to head with any questions. I hope that made sense to everybody.
Right.
Over to you.
I'm going to go first. So my question is probably a straightforward answer, but
Hopefully.
yeah. It was something you could see in the pictures, but you didn't specifically talk about it. Cables.
Yes.
I could see a massive kind of cable.
Yeah.
My question is, because of the size of some of that kit that was moving around site,
yes,
why was the decision to leave it all connected rather than just recable it afterwards?
They're MOD cables. Yeah, so they were high risk cables, and we couldn't cut them. We couldn't find a diversion route. We weren't allowed to have only a single route across the River Thames, hence we had to keep it in place. And getting all the permissions and everything that comes through that, actually creating a catenary wire, which we covered in yellow so no one could miss it, that's all been designed, touched the structure, and we actually anchored it back to a signal post foundation. We removed the signal post and attached this to the signal post foundation. But we simply couldn't move them, so we had to create this catenary wire. We had a watchman throughout all the work, so there was someone who was there to make sure we didn't hit these cables. They were important cables. And one of the things that did become interesting is on this far side of the cables, trying to you had to take the whole crane down to bring it down under the cables, to take it under the cables, to build it back up again. So it did add a couple of stages to it. And in terms of reinstatement, we ended up with a machine landlocked on that side, which we brought onto a barge and brought it back round so that we could do that reinstatement and finalise that far side. But yeah, no, it's a really good question. But we simply couldn't move it, so we had to bring that constraint in and work with it. But adds a bit of colour to the photos.
Yeah. No, thanks. Okay, we got any questions in the room, Gary?
Consents.
Yeah.
The piling in the River Thames.
Yeah.
How on earth did you manage consents on such a quick timescale? Were you using your emergency powers as a statutory undertaking?
I wouldn't describe that. I wouldn't say it was emergency powers. We had the EA out immediately, and because it's outside the working in water window, basically I sent them updates almost daily, photographs, updates. We from a navigation perspective, I became a harbour master. From a more fisheries diversity perspective, permitting perspective, we had a really helpful permitting officer who understood the emergency nature of the works, and actually
So they must have been shortening some of their standard processes.
Yes, they absolutely did. And the assurance they did in a similar way to our engineering assurance, it was progressive. It came to site, we said, this is what we're going to do. Here's our RAMs, here's our mitigations. This is how we're going to do it. So they'd been involved all the way through, but essentially they recognised the emergency nature of the works and supported that. But there was a lot of close engagement to make sure that everyone was comfortable with what was going on. Yeah, go ahead.
Martin Roach, retired former London Underground engineer. Claudia, in your presentation, you didn't mention costs at all. So during that initial week, those few days brainstorming,
Yes.
Did you set out an outline budget for the project, and how was that monitored, and what sort of leeway did you have?
For us, the programme being as short as possible was the biggest issue. The costs associated with the train operating companies and the compensation of the industry was significant. So actually the biggest drive was doing it as quickly as possible. There were elements of procurement that we we had to expedite, and we paid for the privilege of expediting some of those procurement. It was on an emerging cost basis. We didn't know where we were heading, but we had a budget figure that we were working to, and we understood where we were at from the beginning, to be honest with you. The cost of work's done, and that forecasting of understanding where it was, all the change pretty much came through me and my commercial team, so we understood where that was heading. Everything was thought about from a, right, who needs to know this? How much is it going to cost? Does that meet the programme? Do we need to change our solution or change our supplier in order to meet the programme? Because the programme financially was significantly more important, significantly more leading than probably some of the direct costs of the construction. So the programme was the leading factor.
I mean, this disrupted our economy, didn't it?
Yes.
This wasn't just a railway disruption. This
No.
was...
So and this is where I'm kind of, you know, we did take those couple of days at the beginning, which you could say is almost slow time, but it allowed us to absolutely nail that end date. And with programme being so important, the compensation, allowing the freight trains to plan, even they don't necessarily let the end date, they could plan it. I can't remember how many zeros the daily the daily compensation was, but it was significant, and the 24 hours we saved was a lot of money. It was worth doing, to be honest.
You must be looking at $1 million a day in
Yeah, I can't remember the zeros.
schedule. Is it schedule? I never remember schedule.
Yeah, schedule 4 or schedule 8, one or the other. Yes.
Yeah. It must be that.
Yeah. So
Somewhere on that
we
level.
were driven by programme, and we made decisions based on engineering assurance and then programme. So many hands.
Yeah, I appreciate your effort in fixing that particular program, very nice program, in just 4 days.
Yeah.
And can I know, when it is publicized, has there any float considered?
Oh yes. Yeah, so we'd considered where we thought we were at, and we added risk in as we went in terms of understanding. But what we didn't want to do was go too conservative, because actually that also doesn't provide confidence. What we did say was this was the date, and these are kind of some of the assumptions we're making. We had a very wet very wet April when we were demolishing. But when we were rebuilding, it was actually pretty dry. So our compacting and our reinstatement was, we were very lucky with the weather. So it goes both ways. We were probably slightly behind with the weather of when we were demolishing, but we got ahead with the reinstatement. So yes, we built risk in, but we wanted to be really fair and reasonable, otherwise you blow your confidence.
Yeah, Robin Marcus, a signalling engineer, and obviously not a civil engineer. I've got a question about the bridge deck.
Yeah.
And you mentioned earlier on about the weight of all the ballast and all that sort of stuff on it. Now, for my railway career, I've worked on a number of those bridges from a signalling engineering point of view, and they used to have longitudinal timbers with no ballast.
Yes.
Was that how that bridge was ever put in the first place?
Not for the last 100 years since it was rebuilt in 1917.
So obviously, when the original bridge was built in, they calculated that load of all that ballast and.
Yeah. Yeah. So it was all considered. I think the thing that can be reviewed is when you have a track issue, you may choose to add additional ballast as you've tamped it, and that additional weight. You know, you're almost, you know, that you're playing off the two elements of enough ballast to secure and maintain your track geometry, but not adding too much that you're changing the loading on a bridge that may be close to its capacity. But that cross-asset management and cross-asset understanding, I think we are getting more mature as a business, but maybe not in the 1950s when probably the problems started to become more apparent.
Could we take the question online first?
Oh, sorry.
He's just been waiting a while, I think. I don't know.
I've got one from Jay Carroll. Hi, Jay. How have you found implementing these lessons learned on your other projects since closing the gate on Nuneham? And what advice would you give to others in successfully implementing these lessons on other projects?
Thank you for the question. So in terms of implementing the lessons learned on in other works, so the one team piece is really important for me. In Wales and Western, we are heading into single supplier frameworks for buildings and civils, and we are about to consider retendering the reactive version of this. So those single suppliers, really making sure you have a trusting relationship with that supplier and their supply chain. We are implementing that already. I was very fortunate that for the last 6 years we've been in a long-term relationship with Balfour Beatty. Our working relationship is well established, and that definitely came into play, and we're looking to recreate that in a new contract that's being tendered. So I think that's a big part of how I'm influencing it in our region. The other bits and pieces with regards to communication and stopping and pausing. The stop and pause actually comes up almost weekly for me in the reactive space. When we have a struggle with an earthwork, we have a landslip, or we have bridge issues, pausing, let's have a conversation about this. That is step one in my world, in terms of actually being strong enough to say, right, let's understand the issue, let's understand the engineering of how we're going to solve it and play it through. And not only for ourselves, but those third parties, be it planning a possession, be it putting a TSR on, be it speaking to the Environment Agency, landowners, all of people like that. It might only be a half an hour pause. It doesn't have to be 3 or 4 days. It can be a half an hour, but acknowledging that with the right people in the room or on Teams has kind of come day to day for me. And as people start getting back to the office, it's easier to say, let's all go and sit on this sofa to have this quick conversation. Let's all talk it through, as opposed to all going about it individually. And communicating externally, be it doesn't all have to be Twitter, and it doesn't all have to be BBC, a letter to the local neighbours, or when we're out on site, being warm and friendly, your traffic management operatives being engaging everybody, so there's a real positive attitude outside that's being shown to third parties, is really important. But that probably again ties back to the one team, that people are happy to be there, and that culture, it goes a really, really long way. And I'd really focus on culture in a team, to be honest with you. I don't know if that answers Jake's question. Sorry, is it Jake?
Yeah, the existing trusses are quite old, about 100 years old. Yeah. So did you have any problems with the fact that it's old steel, and you are, I think, you're connecting new steel to it?
Yes.
So what were the issues on that?
So we actually did some small pieces of steelwork repairs to the bridge whilst we were there as part of the assessment and just understanding it. The connecting new steel to old steel, the rivets versus new high tensile bolts, those connection details, actually it's kind of normal engineering at the moment for us, because with so many repairs that we were repairing bridges rather than doing new bridges, that those connections and those details are kind of what standard details are there for. We didn't have too many issues with regards to that connection. Removing the rivets was pretty hard going. They were substantial rivets that had been there for a long time, worn down, and the rivet busting was as noisy as you'd expect, to be honest. But we haven't had any concerns around how they connect, other than, changing from rivets to high tensile bolts.
You didn't do any welding onto the old steel?
No, we did welding within its existing, but we didn't cross weld, if that makes sense. Yeah, we just did normal bolted connections between the two.
Okay, thank you.
I mean, this is amazing, and what you see again and again when the rail industry has a crisis, a specific infrastructure crisis like this one, they were brilliant. Oakhampton, this one, there was a temporary station in Cumbria that we built in like 6 weeks or something. I'm sure outsiders, and even as an insider, it puzzles me, never mind what the general public must think, is this disconnect between what we can do in a crisis and the way that we deal with projects when we're not in a crisis, where we take a very long time and spend probably too much money and potentially take too long over the design development, process before we actually get to site. How do we, I mean, obviously you've shared some of the cultural things that go into that, but we must try and pull what we do day to day back towards. We'll never get to what you did here. You know, that's understandable, but it seems. I'm going to phrase it. The same people that delivered this are right now probably sitting in meeting after meeting after meeting, discussing projects that are dragging on. How can we get this attitude into some of those normal projects and get away from, you know, death by meetings and, you know, 3-day IDCs and things like that? How can we get back to
I was going to say
an affordable design development process, I suppose?
I mean, I guess fundamentally and at a business level, we are working hard to embed the SPEED principles, with SPEED being an acronym of that pragmatic and efficient delivery. It is behavioural, it's attitude, and it's going to take a long time to change that. And I think looking at progressive assurance, trying to make the assurance in at every stage as iterative and as engaged as possible is going to be where it's at, because actually you need everybody to come along on the journey rather than stage gate every single thing, and actually work a little bit more concurrently rather than I've done my bit, here is your piece of paper. And that's where the SPEED principles should come into play at least a business level. But I agree, as the reactive maintenance civils person for Wales and Western, we do on much smaller scales, but we do let's go reasonably often.
I think it's also the balance of your overall portfolio, and when something like that happens, the whole portfolio sits to one side while everybody's focused on that one thing, and you can't sustain that for very long before other things start failing because you've not renewed them or whatever.
I guess your cost burn rate and your kind of, how can I put it, mental resilience burn rate must be pretty high on a project like that. So I do understand it's not sustainable from either
and we can't shut railways for weeks on end.
No, we were, yes, there wouldn't, closing the railway for 9 weeks isn't something that's often.
It does intrigue me that, you know, you took risks here, right? You have to, on a project like that, you have to be prepared to take some risk. And yet as soon as we step away from a crisis like that, we seem to be not prepared to take any risk. I think that's something we've got to be more prepared to. I'd say, I mean, we work with all network rails regions, and I'm not just saying this because you're here. The Wales and West region, I would say, are the closest to getting it right that I've seen. We're working with you on a project that I can't talk about here, but it's not that level of crisis, but it is a significant problem, and you're seeing some of that same kind of behaviour and can-do attitude. Some of the other regions in network rail are right at the other end of the spectrum, and still.
Well, that's recorded now.
Yeah, no, I'm happy. I'm not going to name them, keep it anonymous, but we are. You know, it's not. We're not where we need to be across all regions. We need to get there.
Was the final conclusion then about why it happened in the first place because the abutment settled?
Yes.
On the photograph, it looked like, apart from the wing wall, which of course fallen to bits, was the abutment itself fairly solid?
Yes, there was a fairly substantial crack through the centre of the abutment. So essentially it was working in two halves. So there was an element of differential settlement between the two halves. Yeah. But that was the only sign of distress in the abutment itself. The signs of distress were in the wing walls and at track geometry level.
And that's because the abutment had got down and the wing walls hadn't. So they sort of interacted and pulled each other apart.
Yes.
But that solid brick abutment, really, it did quite well, didn't it?
It was very well built, and actually it was a very thick abutment in terms of its footprint. It was a solid construction, which you'd probably expect from a structure that was built 150 years ago.
So it's just settlement under the foundation, really. That's compression of the soil
over the course of time.
Is there any possibility this is climate change related? Is that a discussion that's been had?
I haven't been party to any discussions along those sort of lines. As with regards to, there wasn't particularly signs of scour or anything that might be linked to the river or river velocity or debris. That wasn't certainly anything that I've come across. There's plenty to review looking back, if that makes sense, and doing more asset management review.
The big concern is that there might be other Nunehams out there in the future.
Catch
them before they
become that.
Yeah, and but I think one of the things that certainly the asset management team have looked at or are looking at, I wouldn't want to speak on their behalf, but that mixture of when something was built, the loading conditions and loading parameters in which it was designed under versus the changing conditions. The DCL has significantly increased the number of chains, the weight of the trains. Those freight are incredibly heavy. The conditions on which the structure was built versus what it experiences now is probably quite a significant difference. But I wouldn't want to speak on asset management's behalf.
On that same line, have any measures been taken on the northern abutment of the same structure to make sure that nothing happens again?
We did have a look at the north abutment. We did a full review of the structure. The northern end is actually a couple of arches as well. So it's actually you've got the spans over the river and then 3 arches on the northern side, which we've all assessed and reviewed and actually aren't showing any signs of stress at all. And also the other thing is the northern abutment is set away from the river, and it's got timber fenders and it has a tow path. So actually that interaction between the river and the structure itself, there's significantly more distance if water was to be considered one of the causes or contributing factors to the southern abutment issue.
Did you do any geotechnical investigation?
Yes. So we did geotech investigation throughout September and October 2022 while we were trying to look for the root cause, trying to understand it once these symptoms became progressively worse, to try and understand where we get to bed, where we got to some solid ground. We did some GI on either side. And as I said with the piling, is we actually never quite found really good stuff. So the ground investigation was a lot of alluvium, a big fix of alluvium, and the shale as you got further down wasn't going to be end bearing vitals as a solution. So we now know quite a lot about the area in terms of understanding the root causes of trying to back calculate what may or may not have happened.
You've got all the piling records.
We've got all the piling records. We did. It was really interesting engineering as we went through, and really interesting to find out more and more about the asset. We didn't necessarily want to find out as much as we had to, but it was really interesting as we went through.
I'll ask one more.
Yeah.
And then we'll round up. So at the end, you said handed back in the June, 7th of June, I've written down there. And then there was about 3 months demobilising.
Yeah.
How long was it for all of that period where you were monitoring settlement, and what sort of monitoring did you have to do? It's a massive amount of material.
Yeah. So there was track monitoring on it. We had structures monitoring on it, even throughout after we handed back. Obviously, from a track geometry perspective, handing back to maintenance and talking to maintenance, they still have their normal maintenance regimes, the track recording trains. So getting quite a lot of dynamic data, and for about probably 8 weeks up until and after the follow-up tamp, we were track monitoring, structure monitoring. We saw nothing. It was solid as a rock, as it were, which is really positive. And the follow-up tamps were in the summer. We'll probably have another one just to make us all feel warm and fuzzy about it.
Okay. If there's no further questions online, I guess we'll wrap up. So quick final round of applause. I love sessions like that because that, for the most part is highly civils biased, and that in itself is interesting. But I think you could tell by the engagement in the room from people of various disciplines that there's an appeal, isn't there, for this kind of thing, this kind of reactive, let's all come together with one industry sort of approach. And I think Gary, right, it brings out the best. For whatever reason, it brings out the best in us to be able to showcase what a great industry it is. So yeah, brilliant stuff, and great pictures as well. Good to be able to visualize, because some of those activities are just not our normal kind of work, are they? That was quite impressive. So thank you very much. We won't hang around too long. Month's time, we've got the Severn Tunnel presentation. So it'd be great to see everybody back for that. Good turnout today, and thanks for all the questions. I think that really made the discussion a lot more interesting at the end, and it brought out a few extra bits and pieces. So thank you again, and see you in a month.